In this video, we'll take a look at the first two sections of Chapter 17, Properties of Inequalities and Solving Inequalities. So just to review inequalities, remember that it points towards the larger number. So if you look at the equality and inequality, okay, the larger number, the inequality points towards the smaller number. The signs that we're going to use are the equal, not equal, greater than or equal to, less than or equal to. So just looking at some inequalities on a number line to remind you how they're graphed. If the symbol is greater than, we graph it with an open circle. X is greater than 5, has an open circle on 5, and points to the right. So that means X represents all numbers greater than 5, even 5.0001. That's why we represent with an open circle. Less than, X is less than -1, open circle on -1, pointing to the left. Greater than or equal to is a solid circle because this could equal 3 as well as be greater than 3. So the solution set is 3 and everything greater. Less than or equal to is a solid circle, and then pointing to the left for X is less than or equal to 5. So some properties of inequalities. I'm going to start out with an inequality that's true. A true statement is that 6 is greater than 2. Okay, that's a true inequality, true statement. So property 1 says that you can add or subtract the same number to each side of an inequality and it's still true. So property 1, if I add the same number, add 3, I get 9 is greater than 5, that's still a true statement. You can subtract the same number from both sides. 9 is greater than 5 if I subtract 4 from each side. 9 minus 4 is 5. 5 is still greater than 1. Okay? Second property says if we start with a true equality, 6 is greater than 2, you can multiply or divide a positive number to each side and it's still true. So if I divide both sides by 2, I get 3 is greater than 1, that's still true. If I were to divide by or multiply both sides by a number. Okay, let's say I multiply both sides by 6. 6 times 3 is 18, and that's still greater than 6. So that's property 2. Property 3 is what you have to remember when we're solving inequalities. If you multiply or divide a negative number to each side of an inequality, the inequality is reversed. So if 6 is greater than 2, and we multiply both sides by a negative number, let's say -1, I end up with -6 is greater than -2. That's not a true statement anymore. If you take a look at a number line, there's 2, 6. 6 is greater than 2 on the number line. But if we go the other direction, -6 is smaller than -2, so that's not true. -6 is actually less than -2. So if a number is to the left on the number line, it's smaller, less than. And we're going to use this in the next section. So the inequalities we've looked at so far are just single inequalities. Greater than, less than, greater than or equal to, less than or equal to. We can also have something called compound inequalities, or inequalities that have 3 parts to them. So for an example, A, to state that 5 is less than 6 and also greater than 2 at the same time, we can write it as 2 is less than 5 is less than 6, or if we go the other way, 6 is greater than 5 is greater than 2. Generally, we put it in less than form. We put it in the order from small to large. So that's got 3 parts to it. B, to state that a number x may be greater than -1 and also less than or equal to 3, we write -1 is less than x is less than or equal to 3. Okay, so that's a compound inequality. It can also be written as 2 inequalities, x is greater than -1 and x is less than or equal to 3. And this is shown in the graph. So if you graph a compound inequality, it's all the numbers that satisfy. If it's an and, or written in this way, it means that x can be greater than -1 and less than 3 all at the same time. All right, third example, by writing x is less than or equal to -4 or x is greater than 2, we state that x is less than or equal to -4 or greater than 2. It may not be shown in this way as a compound inequality with a single x value because this shows x as being less than -4 and greater than 2 at the same time, and that's not possible. Okay, so you have to be careful between an and an or. So this is the picture that might make a little more sense. This is written okay as a triple inequality because x is between these two numbers. We can't write it this way because x is not between. In this case, x is greater than 2, x is less than or equal to -4. There's no way to write that as a single inequality. All right, so here's a couple of practice just to graph on a number line. The first one, x is greater than or equal to -1. So we draw a number line. Decide whether or not you have an open circle or a closed circle that's greater than or equal to, so that includes -1. X is greater than or equal to, so we shade the right-hand side. Next one, x is less than -300. Well, let me call this -300. 0, 300. Okay. X is less than -300 or x is greater than or equal to 0. So open circle, x is less than -300 or x is greater than or equal to, solid circle, 0. It can't be both of these at the same time. That's why that's an or. It's one or the other, but not both. Number 34, x is in the middle, or y is in the middle this time. So we have -4 is less than y is less than -2. That means y is in between these two numbers. So -4 has an open circle, -2 has an open circle, and it's everything in between, not including -4 or -2. Okay, last but not least, this one, we'll see if it's x is less than, x is greater than 4, and x is less than 3. Well, that's not possible for that to happen, so we can't graph that. The only way that would be possible is if that said or instead of and.